No other planet in our solar system has rings as splendid as Saturn's. These breathtaking rings are so expansive and bright that they were discovered as soon as humans began pointing telescopes at the night sky. The rings appear visible because the ice particles forming them reflect the light from the sun into space, forming the spectacular ring structure. In 1610, Galileo Galilei became the first person to observe the heavens through a telescope. He made history by discovering Jupiter's 4 largest moons. But what's even more astonishing? Saturn is nearly twice as far from the Sun as Jupiter, yet Galileo still spotted its enormous rings that very same year. Saturn's rings are more than just a beautiful spectacle. They are one of the 3 primary components of the Saturnian system, along with the planet itself and its many moons. The smaller icy moons, Enceladus, Dione, and Mimas, appear much closer to the ring plane. The dark shadow cast by the rings on Saturn's surface adds to this breathtaking celestial scene. Like Earth, Saturn has an axial tilt. As it orbits the Sun, its rings are illuminated differently throughout its 30-year-long journey. For half of its year, the northern side of the rings is bathed in sunlight, for the other half, the southern side. But once every 15 years, something extraordinary happens, Saturn's rings becoming edge-on, making them appear to vanish. This is called the Saturnian equinox, a rare event where the sun's rays hit the rings edge-on, making them nearly invisible from Earth. The last equinox occurred in 2009, and the next one has already set in. Get ready for another cosmic vanishing act. But what about the planet itself? Saturn is a gas giant, mostly made of hydrogen and helium. Beneath its thick atmosphere, there may be a small, rocky core surrounded by layers of liquid metallic hydrogen. Saturn's density is so low that if you could find an ocean large enough, the planet would actually float. Saturn's atmosphere is filled with fascinating chemistry. Scientists have detected traces of ammonia, acetylene, ethane, propane, phosphine, and methane. When exposed to sunlight, these chemicals undergo reactions that create stunning atmospheric patterns and storms. While the equinox makes Saturn's rings temporarily invisible, a more permanent disappearance is happening. Scientists have discovered that these rings are gradually falling into Saturn's atmosphere, a phenomenon called ring rain. These are similar to meteor showers seen from Earth in the night sky. NASA estimates that Saturn is losing its rings at a rapid pace. In about 100 to 300 million years, they may be completely gone, just a blink of an eye in cosmic time. To understand the nature of these disappearing rings, NASA's Cassini spacecraft studied how light passes through them and even observed moons stealing and contributing particles to the rings. One of Cassini's greatest discoveries was that the moon Enceladus contributes material to Saturn's earring by venting icy particles into space. Cassini also found mysterious structures called propellers, waves in the rings caused by hidden moonlets. These moonlets, though too small to be actual moons, gravitationally influence their surroundings, shaping the rings into mesmerizing formations. During Saturn's 2009 equinox, Cassini recorded the coldest temperatures ever seen in the rings, a staggering -382 degrees Fahrenheit -230 degrees Celsius. The spacecraft also captured mysterious features called spokes, ghostly streaks in the rings believed to be tiny ice particles lifted by electrostatic forces, much like a charged balloon lifting hair. Saturn's moons don't just orbit passively, they shape and sculpt the rings. Shepherd moons keep ring particles in place, while orbital resonances sweep out certain regions, forming distinct gaps in the rings. Shepherding is similar to how 2 outward lanes of traffic confine the middle lane to stay within a range. Orbital resonances can be thought of as 3 children riding a swing. When all of them push together, the swing reaches the farthest point. Similarly, when the gravitational pull of the moon matches the pull faced by the ring particles due to other moonlets, that region of the ring feels the effect of the magnified force, and this is called orbital resonance. Saturn's rings are a fleeting wonder, a cosmic masterpiece that won't last forever. But for now, they remain one of the most stunning sights in our solar system, reminding us just how dynamic and ever-changing the universe truly is. Could Titan support life? Titan, Saturn's largest moon, is one of the most intriguing worlds in our solar system. With a thick atmosphere, vast liquid methane lakes, and complex organic chemistry, Titan is considered one of the best candidates for harboring extraterrestrial life. Titan's atmosphere is primarily nitrogen, just like Earth's, with a touch of methane. But what makes it fascinating is the presence of organic molecules, the building blocks of life. If you enjoyed this deep dive into Saturn's rings, don't forget to like, share, and subscribe for more cosmic wonders. Stay curious, and keep looking up.